Okay, as we still have a lot of ground to cover, I figured that we might be running out of time. So I've decided to make the pre-processed scripting part as well as going over homework 4 into videos so you guys can watch online and self-study to save us some time. Alright, so in this video I'm going to demonstrate running a pre-processing script. And so up till now, we've actually gone over, we've gone over all of the pre-processing steps. So just a quick recap, starting from loading data sets, like loading set files into your EEG-Lab graphical user interface. And then we also added channel locations, which actually reads a file from one of the standard montages inside your inside a subfolder within your EEG-Lab 2022.1 folder. Okay, that's a little bit complicated. Anyways, so yeah, adding channel locations, and also creating an event list to add the event code structure to the EEG data structure, and also bin assignment with the BDF, the bin descriptor file .text, and re-referencing, and also epoching and baseline correction, which are lumped into the same step in ERP Lab, and also automatic artifact detection with built-in ERP Lab functions. So we did the moving window peak-to-peak one, and also the step-like artifact detection function, and what's that called? Simple voltage threshold. So yeah, that's those are the built-in ERP Lab functions for automatically marking trials that might contain artifacts. And also filtering, which we did this Monday, and I realized that it wasn't really comprehensive because I was a little bit short on time. So hopefully we'll get to dig a little bit deeper and in more detail into filtering next Monday. And finally, we did manual artifact detection, and all these pre-processing steps, except for manual AD, can be achieved using a script. Because with manual AD, you have to do some visual inspection to kind of subjectively decide whether or not to mark or unmark a trial that may or may not contain artifacts. As I've mentioned before, everything you do on your EEG-Lab graphical user interface, like every button you click on your EEG-Lab GUI, has an equivalent command or a corresponding ERP Lab or EEG-Lab function that is being run secretly in the back. And all the functions that you can access through your EEG-Lab GUI, they start with a POP, POP, which stands for, the pop-up GUI window. Alright, so for instance, loading dataset on the graphical user interface actually corresponds to pop load set in programming terms. And also adding channel locations corresponds to pop chan edit, so on and so forth. And the script I've uploaded onto my Google Drive link. And there's also a text file called subjectlist.txt. And so you guys can go ahead and download these two files from my drive. However, before we get started, there is one thing that is super important that you must pay attention to, which is that after you've downloaded ERP 2023, preprocess.m, and also subjectlist.txt from my drive, please do make sure that your files are exactly organized as shown in this figure, because otherwise the script is not going to run properly. Alright, so everybody has this ERP class folder, right? In which there is a Python virtual environment called Vemb, which is not really relevant in this case. And also in the first lab session class, we created an S1 folder under ERP class. So in the S1 folder, there were 6 CNT files, which we merged into an SCT file with the cntconvert.m script, if you still remember. And if your MATLAB happens to generate FDT files, then each and every one of your SCT files is going to have an accompanying FDT file. So if your MATLAB generates FTT files, you're going to have an S1 SET and an S1 FTT in the S1 folder. And also for homework 4, you must have downloaded S2.SET and S2.FTT. However, I don't suppose you created an S2 folder, so what I want you to do right now is to go inside your ERP class folder and create a subfolder named S2 and move or copy S2SET and S2FTT into your S2 folder. All right, and as for the ERP 2023 preprocess.m script file, just download it from my drive and put it directly in ERP class. And also, you should have the bin descriptor file, the S1 BDF 18 bins.txt file, which should reside directly in ERP class as well. And finally, the subject list.txt file, just download it and also put it in ERP class directly. All right, so just a reminder, it is very important to make sure that your files are exactly organized as shown here, because otherwise the script is just gonna throw a lot of errors. Okay, by the way, here's how to download the script and also the text file that I just mentioned. So just log into Cool, find week 13, November 27th, and click on the script, download from drive item. Just follow the link, which should redirect you to my Google Drive folder, where there are two files, one of which is ERP 2023 preprocess.m. A file with a .m extension is a MATLAB script. All right, and the other one is the subject list.txt file. So just download both of these files and put them in your ERP class folder. Okay, so after you've downloaded the ERP 2023 preprocess.m script, as well as subjectlist.txt, and after you've put them both in the ERP class folder, just launch your MATLAB and double click on the ERP 2023 preprocess.m script in order to view the code. All right, so what I'm gonna do is that I am gonna briefly go over, but before I start demonstrating, how to run the script in MATLAB, I'm gonna briefly go over each line of the code in the script, so you guys will have like a better understanding of like the concept behind the program. All right. And so this script I actually wrote like 2 days ago, on 3 days ago on Monday morning, right before class, because I thought we would have some time to get to the scripting part. However, we ran out of time. But anyways, my point is that what I did in order to get the script, in order to write the script, was that I went through all of the steps, all of the pre-processing steps on the EEG Lab graphical user interface. After which, I just went to the command window. If you guys still remember the EEGH command, which stands for EEG history, and then you type EEGH in the command window and hit enter. And it's going to show you a list of the commands or the functions that you have executed. So in this case, I have previously run popload set, this function, which basically just loads an SCT file into the EEG lab memory. All right, and so getting to the script. Oh, by the way, there's one thing that is really important. So when you launch your MATLAB, just please make sure that your current working directory is set to ERP class. So just look at the search bar up here, and just make sure that you are in the ERP class folder. All right. Okay, so about the code. Wait a second. Make it smaller. All right. So about the code, the first line, all EG current set, all com equals EEGLab. This is to launch EEGLab. Because like for some reason, if you don't launch your EEGLab, some of the functions are not going to function properly. So later when you run this script, you will see the EEGLab GUI pop up because that's what the first line does. Okay. And the second line, FID equals fopen subject list.txt. Basically, this line just tells MATLAB to open the file, the text file, subject list.txt. And let me show you what the text file actually is. So basically, subject list.txt, it's a very boring, plain text file that has 2 lines in it. So the first line is subject is S1, and the second line S2. So basically, the purpose of passing this text file to the script is to have MATLAB read this text file in order to in order to import the corresponding subjects data sets. Since in this case we only have 2 subjects, S1 and S2, I just put both of them here in this text file. All right. And so basically FID, FID actually stands for file identifier. So as a side note, I think this is actually a very common error where, like, suppose you're running a MATLAB script and you run into an error message along the lines of invalid file identifier. This means that most likely there was an issue with reading files or opening files in MATLAB. So yeah, invalid file identifier. All right, and then we get to this while loop. So this basically what this while loop does is that it reads this subject list.txt text file line by line until there are no more lines left. So in this case, since there's only 2 lines in this text file, this while loop will get executed twice. And the fourth line, sub equals f get l, which stands for get line. FID, it just the function for getting the lines in the text file. All right. And this NMHEOG20, well, this is actually, so if you guys still remember, when we did the auto AD process, we did 2 rounds of, what's that called? Step-like artifact detection, right? And the purpose of the first round was to ensure that the participants did not have any horizontal eye movements during the time when the critical word was being presented on the screen, which corresponded to 0 to 200 milliseconds post-stimulus onset. And during this round of step-like artifact detection, the threshold that we're using will be a customized threshold because everyone like moves their eyes horizontally to different degrees, and each subject has their own like customized threshold. And so in the original script, what they did was that they had a text file where they kind of like detailed the individual thresholds for each of their subjects. But in this case, like just for demonstration purposes and for practicing purposes, we're just gonna set the threshold to 20. So it's a fixed constant here. So I just put NMHEOG equals 20 over here. All right, and then the input file path and output file path. So basically, the input file path is the path from which this script will read the set files, and the output path is the path where the preprocessed set file will be stored. All right. And so basically, up till now, we're just like defining the parameters for this script and getting to the loading dataset part. So basically, EEG pop load set is the function that loads set files into the EEG lab memory. And EEG equals EEG check set is a function that kind of checks the consistency of the set file. All right. And then adding channel locations. This part is a little bit more tricky because if you still remember when we did like edit channel locations on the graphical user interface, there was this pop-up window where you could modify the path to the channel montages. And since everybody's MATLAB resides in since everybody's MATLAB might reside in a different directory on your laptop, you might need to find where your standard 1020.elc file is, and just basically you have to modify this path over here. So in this case, my standard 1020 ELC is just located in a bunch of subfolders in ERP Lab 2022.1, which is in the MATLAB folder. So you might need to change this, but if you really don't know how to change your path, it's okay, because I've done some exception handling here. So basically what exception handling does is that there will be at least two blocks of code. So the first one is the try block, where the program will try to execute a piece of code. However, if there is an error, this block of code will skip to the second block, which is the catch block. And so in this case, in the catch block, I'm just telling MATLAB to do nothing. So if your program, if your script fails to load a file from this directory because the directory is incorrect, this will normally give an error. However, since we've done some exception handling, it's gonna skip this error and just do nothing. So theoretically, it's not gonna cause you any trouble over here if you don't know how to modify this path. Okay. And next is the function for creating and exporting the event list. So that's the pop create basic event list function. Is this one. All right, and then assign bins, pop bin lister, where it also reads the S1 BDF 18 bins text file, and then pop epic bin, setting the time window to 200 milliseconds pre-stimulus onset and 1200 milliseconds post-stimulus onset, with a pre-stimulus baseline to correct for. And then re-referencing pop EEG chan operator, where you should pass all the channel re-reference equations to the EEG channel operator function. All right, and then these four functions are the auto AD functions, including moving window peak to peak, as well as artifact what's that called? Step-like artifact detection, and also simple voltage threshold. And as you can see here, there's two pop art step functions, meaning that we are doing step-like artifact detection twice. All right, and then pop basic filter. We're using the IR Butterworth low pass filter with a 30 Hz cutoff and 12 dB octave roll off. All right, and then the last step is to save the data set as with a suffix elist bins b chop autofills dot set. All right, and the final line fclose FID is to close the file because we have previously opened the file with open the subject list.txt file with fopen, right? And in most of the languages I know, it's always a good practice to close the file after you've opened it or after you've executed something. So yeah, that's just a good practice. All right. So now I'm gonna demonstrate how to run this script. Let me clear my command. So to run the script, it's pretty simple. Just go into your command window and type the name of the script, which in this case is ERP 2023 preprocess dot. Just ERP 2023 preprocess. Don't type the .m in the command window because the .m is the file extension, but the name of the file is just ERP 2023 preprocess. All right, so type this in the command window and hit enter. It's gonna start running, and you're gonna see the EEGLab GUI pop up because the first line for launching EEGLab. All right, so as you can see in the command window, it's starting to execute a bunch of commands, and there's some output. So just wait for it to run. That's the AD summary. And the AD summary for S2. So, yep, we're done. So right now what you can do is you can load, let's say we load the preprocessed S1 into EEGLab. So select File, Load Existing Dataset, and select this S1 elist bins B chop autofilled set file. Okay, open it. And you can check if your channel locations is shown as yes. If it is, then it means that when we were doing the exception handling in this trial in this block, it means that the program successfully read the channel montage file. However, if it's shown as a no, then it means that your script did not successfully read this channel montage file. So in this case, you can just use a GUI, hit edit and channel locations to add the channel locations exactly as I had demonstrated in class. Okay. And I think, yeah, I really do hope that you guys get to run the script yourself. And I kind of understand that it might not seem absolutely necessary to run a script at this point. But like just imagine if you have like 30 or 40 subjects, and if you were to use the GUI for each and every one of these 30 to 40 subjects, this would be quite susceptible to mistakes. So one of the advantages of using a script is to reduce the chance that you will make careless mistakes and also boost your efficiency in pre-processing the data. So you have more time and energy to focus more on the, let's say, stats analysis. So if you run into some weird error, just feel free to take a screenshot of the error and send me a message via email. So yeah, that's all for this video. Thank you for watching.